All right, class, today's the 19th. If you haven't already, get the packet from the front desk, or maybe the substitute teacher's already passed them out. Be disciplined with your phones and earbuds. You know, you're not supposed to have them, so don't make it a problem for the sub, okay? The test for this unit, graphing quadratics, it's gonna be probably in trimester 3. I'm just not 100% sure. So I'll deal with that when I get back. All right, first page, obviously put your name at the top. Also a reminder, this is a video, so you can pause it and go back whenever you need to, really easy. So we're graphing quadratics, as you can see. We're gonna label this graph below. We're gonna start labeling, okay, with this, I'll put it so we can see the whole thing here. We're gonna start labeling with the shape of this curve. This curve is called a parabola. Parabola, if you will, but parabola is how I pronounce it. So that's just what it's called, okay? A quadratic equation gives us a parabola. The quadratic is called that's the equation. The parabola is the shape or the curve. All right, something we already know is this arrow right here. That is called the y-intercept. So let's get that written down, okay? Other things to know, other verbs, okay? These two things right here, these points right here, those are called the x-intercepts. So get those written down. They are simply where the parabola crosses the x-axis. Yes, it has two of them sometimes, most of the time, okay? And I'll always will have one y-intercept as well. The next thing, this point down here, where it changes from going down to going up, okay? That's called the vertex, okay? We will need to know these words just so you know. The test will say things like, tell me the vertex, tell me the y-intercept. So you need to know exactly what they are. It's this point right here is the vertex where it changes from going down to up. And then the only other thing we don't have is this dashed line, okay? Okay, that dashed line, as you can see, it goes right through the vertex. That's called the axis of symmetry. So again, axis of symmetry, okay? A couple questions at the bottom. Does this graph open up or down? It opens up, okay? That's what opening up looks like. Opening down would look like this, okay? Does this graph show a minimum or maximum? This graph shows a minimum, okay? You look at the vertex for that. You can see here's our vertex, right? Okay, it's the bottom of the graph, okay? There's nothing below it. If it had a maximum, then it would be this point up there. All right, but this one has a minimum. Okay, I'll probably highlight that so we can see it. So highlight the up, highlight the minimum. Those are the answers. Okay, moving on to the next page, okay? So just recall this stuff. You should probably pause the video and do these two problems. Here we go. It's f of 1. Substitute x in for 1 is 2 times 1 squared. That's what we have to figure out. So we figured out that f of 1 is equal to 12. And then here we're going to plug in 2 for x, so we're finding f of 2. That's 2 times 2 squared. Just substitute x in for 2. So f of 2 equals 18. Oh gosh almighty. I forgot the plus 10. Whoopsies. That's there. Sorry. I was thinking about this next thing right here, this video. That will be a link on YouTube. You can just watch it. I figure it's silly to have a video inside of a video. It might be really choppy too, potentially. So this is a link on Schoology. Watch it. Okay, it's a cute little video. But anyway, we can move on. A toy rocket's fired into the air from the top of a barn. Okay, so hopefully you can picture that. Okay. Its height, h, above the ground in yards after t seconds is given by this function here. So we're going to be using this function a lot. Okay, and it is a barn. I'll draw a red barn. Okay, like some barns are. That's the barn. Yay. And what we're going to do is we're going to fire this rocket from the top of the barn. That's the path it's taking, okay? and it hits the ground. Right there. So that's what's going on. Usually it helps me anyway to have a picture of the problem. So we're going to label the x and y axis. So first, y axis. That is, of course, the height in yards. It says it right there, okay? It's height above the ground. Now that makes perfect sense. H, right there, that'd be the y, right? Y of x, f of x. And then the t is time, and that's in seconds. Time in seconds. All right, so we labeled them. Awesome. At 0 seconds, so at t equals 0, how high is the rocket? Plot this point on the graph. Well, people, just plug in 0. It says t equals 0. Plug it into this equation. H of 0 equals -5 times 0 squared plus 10 times 0 plus 20. And that gets us 20, which is the point 0, that was the t value or the x value, 20, the y value or the h of t value that we found. So 0, 20 is right here. That's where the barn is. That is that spot right there. See me doing it on the left there. Okay, at 1 second, t equals 1, how high is the rocket? So again, the rocket is just this formula. That's all we need to do, okay? So we're plugging in h of 1. Equals -5 times 1 squared plus 10 times 1 plus 20. And we eventually get this to be 25. So we have to plot the point 1, that's the t value, and then 25, the value we just found. So remember, 1 is right here. Like you have to read your graph, right? 1 is right there. So 125 is here, right there. Next, we have to find t of 2. How high is the rocket? Plot this point. Same thing. So h of 2 equals -5 times 2 squared. 2 squared plus 10 times 2 plus 20. All I'm doing is this formula. Don't think I'm doing anything different or unusual. We did this in the beginning of the year. And then we plug all those numbers in our calculator and we get, well, 20 again. So we're going to graph the point 2, 20. So 2 and 20 right there. Okay. And then at 3 seconds, so it's the same exact thing, but 3 seconds. Again, remember, at any point you can pause the video and do this stuff. So here we go. H of 3 equals -5 times 3 squared plus 10 times 3 plus 20. And what that equals is 5. That equals 5. So that's the point 3, 5. Oh my goodness. 3, 5. So 3 is here. 5 is here. Okay. So we have this, what's a rocket fired from the barn, and it goes like this in this curve, right? Like that. So what's the maximum height of the rocket? Well, if we follow the path, what's literally the highest point? This point right here, right? That's called our vertex, by the way. Okay, so the maximum height is, that was our 25 that we found out a while ago. That's right here, right? 25, maximum height, 25 yards. Because remember, it's height in yards. Approximate how long the rocket was in the air before hitting the ground. Okay, so for this here, it hits the ground right here. It's like somewhere exactly there. Okay, so that looks to be like, I don't know, 3.4 or something like that. Okay, 3.2, 3.2, or 3.4, somewhere in that range, depending on exactly in your drawing, right? But it's somewhere around there. Approximately what, seconds. Approximately what time or times will the rocket be at a height of 22 yards? Okay. Well, 22 is here, right? See, that's this right there. That's 22. So right there, that looks to be 0.25 seconds. And also it hits it here, right? Which looks to be, if we look down, again, that's what we're doing, is we're looking straight down from these spots. And that looks to be like 1.75. So it's about 0.25 and 1.75 seconds. It does say approximately, which we know we are just guesstimating as best we can based off our drawing. We know we're not computers. All right, next page. Next page here. All right, so we're going to recall some information again. Given the equation f of x equals 2x minus 5, find f of 2. All right, well, pretty straightforward enough. Just plug in f of 2 equals 2 times 2 minus 5, and that equals negative 1. So we're going to graph the point 2, negative 1. 2, negative 1 right there. And we'll also figure out this one. This g of x is x squared. So g of negative 2 is what we have to figure out. Negative 2 squared. That is 4. So we need to graph the point negative 2, 4. Right there. And we might as well label these. That's g right there. We'll need to, I suppose. Okay, next one. H of negative 2 equals negative 2 squared minus 2 times negative 2. Well, that ends up being 8. So we're graphing the point negative 2, 8. So negative 2, 8 is here, right there. All right, so just more review of that stuff from earlier in the year. So make this bigger, probably could help. All right, so here we go. We're gonna graph this quadratic equation. It's an important step in evaluating models, okay? So we're gonna make a table. Okay, that's what this is, obviously, okay? When in doubt, table it out. Like that's what we'll probably say on occasion. So all we need to do is type f of negative 3, like I'm plugging in this negative 3, it's the x value, right? Into the equation. Negative 3 squared plus 2 times negative 3 minus 2. Okay, so I expect you to do all that. And the numbers you're going to get are 1, negative 2, negative 3, negative 2, and 1. I do expect you to know how to do this. So don't just copy down those problems, those answers, and be like, I'm good. If you don't know how to find them, that's going to be an issue for you. Okay, so we're going to graph this. We're going to plot the ordered pairs on a coordinate plane. So that's right here below here. So we've got the coordinate points, negative 3, 1, right? Negative 2, negative 2. Okay, so on and so forth. So we're going to graph them. So negative 3, negative 1. Or negative 3, 1, sorry. Right there. And then we have negative 2, negative 2. And then we have negative 1, negative 3. And then we have 0, negative 2. And then we have 1, 1. So that's our parabola. We can see it. So draw it in. It's a curve. Okay, it's not a point down there at the bottom in the vertex. It's a curve. All right, next one, same thing. Different problem. If you haven't paused the video before to do it on your own, probably do it now. Because you eventually should get negative 1, negative 7, negative 9, negative 7, and negative 1. Do you see the symmetry here? There should always be some kind of symmetry. You can see it here as well. Okay? It's symmetrical because the shape itself, the parabola, is symmetrical. So we're going to graph all these points from above. So negative 3, negative 1, right there. Negative 2, negative 7 is here. Negative 1, negative 9 is here. 0, negative 7, and 1, negative 1. We can see our parabola. There it is. Okay. Don't need you to be an awesome artist, but you do have to make that curve. All right. Next page. Okay. Now you should try this. You should definitely pause the video. And hopefully you actually paused the video and eventually found out that these are the numbers that go in here. Again, noting the symmetry here. Noting that symmetry with the numbers, okay, with the f of x values, the y values we just found. And when you graph them, it should be, of course, negative 1, negative 3 right here. 0, 0, 1, 1, 2, 0, and there we go right there. You can see this parabola. Okay, all we're doing is graphing a quadratic equation. This here is a quadratic. The picture itself is called a parabola. And a little summary. Again, you should do this on your own right now. Pause the video. And hopefully you actually pause the video, and here we go. This ordered pair means it's a 1, 4. This one, 0, -5. And this one, -6, 0. So I'm going to graph all those. 1, 4, right there. Okay, that's B. 0, -5, right there. That's C. And -6, 0, that is D, right there. All right. So that was your notes. The next page, this is your homework. This page 4 is your homework. Do it, okay? In addition to that, there's going to be something on Schoology to do. Schoology. Recording a video. 1 second. Schoology. Okay, so there's going to be something on Schoology for you to do. Possibly, I haven't made it yet. Otherwise, this page is definitely your homework. All right, that's it, kids. Have a good day.